Assalamualaikum and hello everyone. Welcome to the video for the chemical properties of benzene. In this video, we're going to learn to explain the influence of ortho-para and meta-directing substituents towards electrophilic aromatic substitution reaction. Okay, so for the main reaction of benzene, it will undergo electrophilic aromatic substitution. Okay, so we have our benzene. Benzene is actually C6H6. Okay, so what will happen is that when we have electrophile, we're going to substitute the electrophile with one of the hydrogen at the benzene. Okay, so it could be this hydrogen, so we have 6 possible hydrogen lah. Okay, so that is the main reaction of benzene where we're going to substitute the hydrogen with our electrophile to form our product. Okay, so that is the recap of the reaction of benzene. Right now we're going to look at our notes on page 7. So let's look here. For a mono-substituted benzene, mono, so it means that we have one substituent. Okay, so this is benzene, we have one substituent kan? So this is what we refer as mono-substituted. So when it's treated with electrophile, it will undergo 3 electrophilic aromatic substitution, which yield a di-substituted benzene. Okay, so what does it mean? So we have mono-substituent. So when we react it with electrophile, the electrophile will replace one of the hydrogen in the benzene. Okay, so when it replaces one of the hydrogen in the benzene, so right now we will have 2 substituent on the benzene ring itself. So this is what we call di-substituted lah. Okay, however, for this one, it could yield 3 products. Now, you could find here. It could undergo 3 electrophilic aromatic substitution. Okay, so we have 1, 2, 3. So here it mentioned that when it have di-substituted benzene, this product could be identified using the description ortho-meta-para. So here it's recap back to what we have learned during the naming. So what does it mean by ortho? Ortho, it means that the substituent is actually on carbon number 1 and 2. Meta is on carbon number 1 and 3. Para is on the carbon number 1 and 4. Okay, so how do we know the numbering? So for the number 1 here, usually, for number 1, we're going to start with the mono-substituted, this one lah, the original substituent. So for example, here I denote my substituent as A. So this A will be my number 1. Okay. So back to this product here. So kita tengok sini. So this one will be carbon. Again, the one that containing the original substituent with number 1 lah. Okay, so here is 1 and 2. So here this is what we call the ortho product. Here 1, 2, 3. Okay, the substituent is actually on carbon 1 and 3. So this one will be meta. And this one, the substituent will be number 1, 2, 3, 4. Will be at 1 and 4. So this one will be the para. Okay, so again, if the substituent is actually on carbon 1, 2, ortho, 1, 3, meta, 1, 4, para. Okay, but how to determine which one will yield the ortho, the meta, or the para? So we're going to see, we're going to learn is these two group is ortho-para directing group and meta directing group. Okay, so what does it mean? Okay, so if we have our substituent, the A itself is to be our amino group. So for example, we have N. Okay, it's either attached to 2 of the hydrogen or attached R ni. So it means our carbon lah. R ni means that our carbon kita. Okay, so OH is our hydroxy. OR ni is actually our ether. Ether is the one that we have COC. So this is what we call our ether. The homologous series is ether. The functional group is alkoxy lah. Okay, alkyl group, again, our carbon. Halogen could be our fluorine, chlorine, bromine, iodine. So that is our halogen. Okay, so if we have this substituent on our benzene, okay, so our product will be at the position of ortho and para. So again, why is ortho-para? Sebab here on carbon 1, 2 is our ortho and 1, 4 for our para. Okay, so when we substituted it will form the same product, but then it is at different position. We will have 2 different products. Okay, so that's for ortho-para directing group. for the meta-directing group, okay, it will be our CN, our cyanide, okay, and then we have NO2, our nitro. Here, the CHO, ataupun this one, if you see your C double bond O. Okay, so for this case, I'm just gonna, this one, if you see your compound, we have C double bond O, it's either at hydrogen, if we have another carbon, if we have OH. Okay, so if you found this one, it will be the meta-directing group. So it means that, again, the original one, the substituent will be carbon number 1, 2, 3. So 1, 3 will be our meta-directing group. Okay, so that's the directing group. So let's look based on the example lah. Okay, so let's look for example A. So here we have our benzene. Okay, we have our substituent attached to it. Okay, it will react with Cl2 and AlCl3. So look here, our NH2. So what is the directing group? Is it ortho-para or meta? Okay, so NH2, as we can see, it is actually ortho-para directing group. So it means that the position will be at either. Okay, so I'm just going to label it first here. Number 1, 2, 3, 4. Okay, so I know that I will substitute the electrophile of this to carbon number 2 and 4. We will have two different products. Okay, but what will be the electrophile? Okay, so let's look back based on what we have learned previously. So if the reagent is the halogen and our Lewis acid, what we're going to do is actually we're going to substitute the hydrogen with the electrophile. In this case, the electrophile would be the chlorine or bromine. It depends on your halogen here lah. Okay, so I'm just going to write down again what I'm going to substitute. So here I write down I'm going to substitute the hydrogen. It's with the chlorine or bromine. Okay, but then again for this one, it's actually ortho-para directing group. So it means that we have two different products. Okay, so how we're going to draw it? Draw our benzene again. So we have the original substituent is NH2. Okay, and then we know that we're going to substitute the hydrogen with the chlorine or bromine. Again, for this one, the ortho-para directing group. So it means that we have on the position of ortho, position number 2. Okay, so again, this will be my Cl. Okay, so this one is only the ortho. Okay, how about the para one? So for the para, it will be position 4. So here 1, 2, 3, 4. So here will be my Cl. Okay, so for the ortho-para directing group, we will have two different products. One is the ortho, 1, 2. One will be the at the para, 1, 4. Okay, so that will be the answer for question A. Okay, so now let's look for question B. So for question B, we have our nitro. So nitro is actually an example of meta-directing group lah. So kalau NO2, then it will be the meta-directing group. So again, what we're going to do is actually we're going to substitute the hydrogen with the bromine. But we can't just substitute anywhere that we want. It must be at the meta-directing group. So this one will be number 1, 2, 3. Okay, so now we're going to substitute it the hydrogen with the bromine at carbon number 3. So carbon number 3, so 1, 2, 3 here, so we'll substitute the bromine. Okay, so for the meta-directing group, we only have one product lah at meta. For ortho and para, we have two. Okay, so you have to check what is your substituent. Okay, so now let's look for example C. So example C, we have our benzene and we have our isopropyl here. Okay, so what is this one? Okay, so is it NH2? Okay, does not have any N. It's not OH. We don't have any O. So this is what we call our alkyl group lah. Okay, sebab our substituent only our carbon ni kan. This is our isopropyl. Okay, so this one again it will be the ortho-para directing group. So you know that this is number 1. So the number 2 it could be this one, to your left, or it could be your downwards lah, to your right down here. So any of position, so 1, 2, 3, 4. So we know since this is a ortho-para directing group. Okay, so I'm just going to write down until 4 lah. Okay, but right now this is the reagent, concentrated HNO3, concentrated H2SO4, 50 to 55 degrees Celsius. So what will be the electrophile? So for the case of halogen and the Lewis acid, Okay, we're going to substitute on the chlorine with bromine. For this reagent, okay, what would happen is that we're going to substitute our NO2. That will be our electrophile. So I'm just going to write down here. So for this one, what will happen is that we're going to substitute the hydrogen with NO2. Okay, so it's back to what we have learned previously. For the nitration reaction, the electrophile is NO2 lah. So what will be the product? So we have our isopropyl benzene here. Okay, and then it must substitute NO2 on the carbon number 2 itself. So here is NO2. Okay, and then since this is the ortho, we have to show the para as well lah. So for the drawing of the structure, it's actually N is the one that is bonded to our carbon. So this one you have to draw N lah. N, okay, O2 boleh terbalik macam ni. Okay, so this will be the product. Okay, so for the Ortho-Para directing group, so again, it does not mean that this will be our carbon number 1. We have to check where the original substituent, that will be our carbon number 1 kita lah. Okay, this will be carbon 1, carbon number 1. Okay, so actually it will be easier at the start. You determine which one is the number 1. And then you're going to number it based on whether it's Ortho-Para or it's the meta group. Okay, so for example DEF, I'm just going to show the answer here. So you should try yourself. You could pause it here and try yourself and then check the answer. Okay, so this is the answer for question D. It's actually the meta directing group because we have the C double bond O. Check the C double bond O. 1, 2, 3. You can also number it as 1, 2, 3 lah. If you have the answer to be the position at here and O2 pun acceptable. Again, this one you have to write down since the carbon is attached to nitrogen. So first you have to draw the N first and then the O2. Okay, so question E, COOH meta. So, okay, ortho meta para. So, at carbon number 3 here. You could also draw the structure, the bromine to be at the bottom here pun boleh juga. And the last one is the, okay, so we have the O. This is actually our ether lah, COC ni. Because we have oxygen, carbon, carbon. Okay, so that is actually all what you're going to learn for the ortho meta para directing group.